Today we're going to look at 4.3 mixed and the entire radical. So just take a quick read on how this occurs. So we have two numbers inside a radical, then we can bring them out and we'd get the same answer. For example, 16 times 9 is the same as the square root of 16 plus the square root of 9. As you can see, 16 times 9 is equal to 144, which is the square root of 144 is 12, whereas 16 times, or the square root of 16 times the square root of 9, square root of 16 is 4, square root of 9 is 3, so 4 times 3 is 12, so same answers. So, and then if we look further down here, we can see at how you can simplify the square root of 24. Now, when there's no number in here in the index position, then you must assume it's 2. If otherwise, it has to be told 3 and a 4, but there's nothing here, so that's a 2. So we simplify this as 4 times 6, square root of 4 is 2, square root of 6 is a fraction, but we don't want that, we just want to keep everything as whole numbers, so it's 2 square root 6. Same with down here, 8 times 3, and we're looking at a cube, and 8 is equal to 2 times 2 times 2, so because we're a group of 3, we bring it out, and we then leave the 3 of itself because we do not want to have, once again, decimal numbers, so it's 2 cube root 3. However, we can't do 24 because the number is close to 24. If for example, I'm looking for 4 numbers, so 2 times 2 times 2 times 2 is equal to 2 times 2 is 4, times 2 is 8, times 2 is 16. Oh, I guess it would work. But we don't have a number that will go into 24 once we get the 16 out of there, so or do we? No, we don't, so that's why it can't work that way. So if we're going to write radicals in simplest form of prime factorization, remember prime numbers are numbers such as 1, 2, 3, 5, 7, 11, 13, numbers that only have 1 and itself as a multiple, and we want to factorize it, so we want to bring in brackets and bring it down. So here's a couple examples. Take a look, and I can show you how to do the try part. So take a look, see how it's done, stop the tape, and then try it, and then check your answers after. So square root of 80. So I know that 8 times 10 is equal to 80. I know 8 is equal to 2 times 4, and I know 4 is equal to 2 times 2. 10 is equal to 2 times 5, and we're done there. So the prime factorization of 80 is equal to 2 times 2 times 2, which is 8, times 2 times 5, which is 10. So that's it in prime factorization. Now, if I want to take it one step further, because there's a 2 there, I'm going to take out a group of 2, so I throw that out. I take out another group of 2, throw it out, and now I got 2 times 2 square root 5, because there's only one 5, which equal to 2 times 2 is 4 square root 5. Same with here, we have cube root 144, which 144 is equal to 12 times 12. 12 is equal to 3 times 4, which means this is 3 times 4, and 4 is equal to 2 times 2, and 4 is equal to 2 times 2. So the cube root of 144 is equal to 2 times 2 times 2 times 2, and that's on the cube root sign. So 1, 2, 3, 4 times 3 times 3. Now this time I have to look for a group of 3 because that's the index telling me. So I have one group of 3 of 2 here, and that's it. Bring it out. So now I have 3 square root 2 times 3 times 3, which is equal to 3 square root 2 times 3 is 6, times 3 is 18. 162, so I know 2 goes in there, and goes in there 81 times, which now gives me 9 times 9, which is 3 times 3 and 3 times 3. So the cube root of 162 in prime factorization is going to be 2 times 3 times 3 times 3 times 3. Once again, the 4 in the index tells me I'm looking for a group of 4 of all the same numbers. So I have 4 3's here, bring it out. I'm left with 4 square root 2, and there's the answer. So Then if you look at later on, that's what you call a mixed radical. Number outside and radical. Now we also have entire radicals. Entire radicals are where everything's inside. So that's entire radical, that's a mixed radical. So either way we can write this that way, or entire radical down to mixed radical. So read this part here, get an idea what it's looking for, and then once you're ready, you can take a look at the example over here on how you convert a mixed radical into radical, and then from there stop the tape and try the 3 questions. Okay, you should have stopped the tape. So now I'm going to put this form here into a entire radical. So the 4's on the outside, once again, have an imaginary 2 there, so it tells me I had to have a group of 2 4's to bring out, so I'm going to put them back in, so I get 3 times 4 times 4, which is equal to 12 times 4, which is equal to 48. Here I got a 3 on the outside, so the 3 is going to go back in, but it's going to go put in 3 times because of the 3 index, so 2 times 3 times 3 times 3, which is equal to 6 times 9, which is equal to, sorry, the cube root, this should be there, so it's the cube root of 54. Last one, 4 on the outside, so when I bring that 2 in, it's going to be written down 4 times. 1, 2, 3, 4, which is equal to 4 times 4 times 2, which is equal to 16 times 2, which is equal to 32. There you go. If you have any questions, then stop and come by and see me. If not, then take a look at the checkups and our worksheets, or even your workbook, which you should be working out of there, and we'll talk to you later. Have a good day.